Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So today I am going to discuss about the current electricity. Basically, this is the part third video, and so I will focus on the electrical energy and all. Okay, how energy is being produced in the cell. So let us discuss one by one. What is actually electrical power? Electrical power. It is defined as the rate of electrical energy supplied to maintain the flow of current through a conductor by a voltage source. Let us consider here I is the current which is passing through the conductor and the charge Q is passing for a time t and the applied voltage is V. Now the power, we know that power is equal to work done by time t. Okay. So how much work done is there? So work done can be written as the potential, right? Potential energy by T, and the potential energy is written as QV. Okay, or work we can write here work done per unit. Work done can be defined as the work done per unit charge can be defined as the potential, right? So here, from here we can find work done is equal to Q into V. So from here we can get QV by T. So Q by T is your current. So finally we have got power is equal to V into I. My power is equal to V by I. We can also write here V square by I, because in place of I we can write V by R. So finally I square by R. SI unit is what? Commercial unit. SI unit is what? SI unit of the power will be watt, and commercial unit is your 1 horsepower. 1 HP is equal to 746 watt. Okay, 1 HP is equal to 746 watt, right? So that is your electrical power. Now what is electrical energy? It is the total work done in maintaining the current in a conductor by a voltage source. So the work done. So work done, from here we can write work done as power is equal to work done by time t, or delta U by T. So electrical energy will be equal to electrical power into time t. So electrical power is your V into I. Just previously only we have discussed. Electrical power is equal to VI. See here. See, this is electrical power and this is equal to VI. So we can put here electrical power as VI into time t. So from here we can get electrical energy. So from here we get electrical energy as VIT. So electrical energy can also be written as I square into R into T. Why? You have to put V is equal to, you put I into R, so you will get this. So you can also get V square by R into time t. So from here electrical energy will be the unit of the electrical energy will be joule, right? Now what is commercial unit? So commercial unit is kilowatt hour. Why kilowatt hour? See here, unit of energy is what? Unit of energy is joule, right? Now, if we talk about the commercial energy, commercially, it is not possible to write energy in a joule, because it will be a very large number. So we have put like this: 1 joule is equal to 1 watt into 1 second. Why so? Because we know that work done or energy is equal to power into time t. Power has a unit watt and time has a unit second. Why we cannot? We can easily increase the unit of the watt as kilowatt. So this can be written as kilowatt. Okay. So 1 kilowatt hour can be written as, in place of second we can change second to hour. In place of watt we can put here watt. See, the unit is same, but the what happened, we have make a dimension enlarged. So 1 kilowatt hour is equal to 1000 watt into 3600 second, because I am talking about 1 hour. So this will be 3600 1230 into joule by second into joules. So from here, 1 kilowatt hour will be equal to 3.6 into 10 to the power 6 joule. So this is the larger unit, right? So 1 kilowatt hour. So 1 kilowatt hour is known as 1 unit, and we use this unit as a commercial unit in the electricity bill. Okay. Now what is EMF? See, EMF is a terminal potential difference or internal resistance. So EMF is electromotive force. It is the maximum potential difference between two electrodes of the cell when no current is drawn from it. For example, this is the cell, right? And there is a positive terminal and negative terminal, but no connection is between positive and negative terminal. It is only the voltmeter which will measure the voltage. Okay. So if no connection is there, it means no current is passing. So if no current is passing, then whatever we have measured the potential, for example, it has potential of 6 volt. So the electromotive force E is equal to 6 volt here, right? That is voltage. It can also be said that voltage in open circuit. Okay. Now, what is internal resistance? It is the resistance offered by the electrolyte or electrode cell when the current flows through it. It is denoted by R. Now see here, you have already seen there is an electrode and cathode, and if there is no connection, so what will happen? No electron will flow. But if you connect it, see if you connect it, so what will happen? Electron will start moving, and internally also electron will move in this direction. So what happened? Resistance is offered by the liquid. Resistance is offered by the electrolyte, and this resistance is known as resistance is called internal resistance. I hope you have understood. So this is all about internal resistance. When a circuit is closed, this will happen only in a this will happen in closed circuit. Okay. So you have now understood internal resistance. Internal resistance depends upon the following factor. First is nature of the electrodes and electrolyte. For example, if there is a battery or a cell, so this is your electrode, the type of electrode, either it is your zinc, either it is your copper, and the electrolyte, it may be H2SO4, it may be HCl, it may be NH4Cl, so anything may happens. Another thing is the temperature of the electrode and electrolytes. So how much temperature is there? 100 degree, 200 degree, and distance between the electrode. If the electrodes are being separated for a large distance, so a resistance will be increased because electron has to travel more. This area of the electrode immersed in the electrolyte. So if the area will be more, so what will happen? More transfer of electrolyte will be happen, so resistance will be less. So these are the four factors which affect the internal resistance of the object. Now what is terminal potential difference? Very important. It is the potential difference between the two electrodes of a cell in a closed circuit. Closed circuit means, see here, earlier case you have seen that there was no resistance, but now we have connected a resistance, and due to resistance what happened? Electron will start flowing, and if electron will flow, so what will happen? If electron will flow, then what will happen? There will be a internal resistance will happen. Okay. So the voltage, definitely if the internal resistance will happen, for example earlier the voltage was 6 volt, but now when current will start flowing, so what will happen, its voltage will go down due to internal resistance, so it may be 4.5 4.8 volt, right? So it means that the terminal voltage is equal to uh, voltage in a open circuit minus the voltage drop. See, the current, if current is I and internal resistance is R, so the voltage drop will be I into R. So this is your voltage drop. Voltage drop. Voltage drop means reduction in the voltage, right? So this is a reduction in the voltage. So I hope you all have understood the terminal potential difference. So the terminal potential difference will only act on the closed circuit, right? So this will always act in a closed circuit. It won't act on a open circuit. I hope you have understood now. Now let us draw the circuit internal resistance in terms of EVR. See here, let us, this is the battery or a cell. This is battery or a cell, and it has internal resistance as a small I, and the current passing through is I, and the external resistance is R. Okay, now we know that we have just derived IR is equal to E minus B. How? Just see, IR is equal to, from here, IR is equal to I into small r, that is internal resistance IR we can write like this. See here, we can write IR is equal to E minus B. So we can write from here IR is equal to E minus B. So from here IR is equal to E minus B by I. Now also Ohm's law, you know that Ohm's law, if terminal voltage is V, current passing is I, and external resistance is R. So the relation will is equal to I is equal to B by R, or B is equal to IR. So we can put here, in case place of I, we can put here B by R. So finally we will get a relation like this: R is equal to E by B minus 1 into R. Okay. So I hope you all have understood this. Now, so you have already understood EMF, potential difference, internal resistance, external resistance, and the current. Now we will differentiate between EMF and potential difference. EMF, which is written as E, and potential difference, that is V. The EMF of the cell is maximum when potential difference between the 2 points when a cell is in open circuit, and the potential difference between the 2 points of difference of a potential between those 2 points in a closed circuit. So it is just see here. If you want to make a closed circuit, you can see here. See, in this what happened? Circuit is not closed, it is opened, and when it is open, no external resistance is not there, so we have to measure the voltage. So that voltage is EMF. But when we talk about the closed circuit, that is an external resistance is being used, so what happened, there is a voltage drop, and this potential difference is known as terminal voltage, because we are measuring the voltage between these two terminal only. But when we talk about the EMF, so it will talk about all over the voltage. Okay, so this is the basic difference. Now EMF, it is independent of the resistance of the circuit, depends upon the nature of electrolytes and the electrolytes, and potential difference depends upon the resistance between the 2 points of the circuit. See, uh, see, if resistance is high, so voltage will decrease. P is equal to IR. So you, okay. So resistance, see here, resistance and current all are dependent. The term EMF is only used for a source of EMF, but it is measured between the any 2 points of the current, okay, a circuit. So I hope you have understood. Now in next class I will discuss about combination of resistance. See, combination of the cells. If you want to combine a cells, so what happens? Will let us discuss. This is the combination of cell when it is cells are in a series. See, this is the cell having E as a EMF, R is the internal resistance. This is the cell having EMF E and R is internal resistance. So there are n number of cells having EMF E and R as an internal resistance. So total EMF will be NE. If 5 cells are there, so 5 into E. If 8 cells are there, so 8E. So total EMF is E. NE. Total internal resistance is your NR. Why? Because is F n number of cells are there, so n number of internal resistance will be there. And now total resistance I'm talking about. So you have to include this resistance as well. So the total resistance will be n small n R plus capital R. Huh. So current will be how much? Current will be total EMF is NE, and the total resistance is NR plus R. So finally we have got current. Now if R, capital R, that is external resistance, it is your external resistance. If external resistance is very much less than the internal resistance, then current is equal to IR. And if external resistance is larger than the internal resistance, then I is equal to NE by R. So the conclusion is when internal resistance is negligible. See, when internal resistance is negligible as compared to the external resistance, the cell are to be connected in a series so that we will get maximum current. See here, in this case what happens? Current, no change in the current happens. No change in current. But in this case what happens? Current increases. Current increases. So it means that if you want to increase the current by connecting a cells many number of cells, so you have to connect the cells in a series. Connect the cells in a series so that your current will increase if its external resistance is greater than internal resistance, that is internal resistance is negligible. Okay, now let us go for a cells in a parallel. Cells in a parallel combination. Cells are said to be connected in a parallel if positive terminal of each cells are connected to a point. Negative terminal of each cell is connected to a point of a negative terminal. Each of the cell are connected to other. See here, let us draw it. If you want to draw the cells which is connected in a parallel, see here, these are the cells, these are the cells, these are the cells, which is connected in a parallel way. And this is external resistance, this is internal, and this cells is having EMF E, and the voltage is same across each one. So see, this is the thing. Now total EMF will be E. Why E? Because the potential difference across the parallel connection will be same. But total internal resistance will be R by N. Why R by N? See here, if there are, let us consider our total resistance, internal resistance, when you add parallelly, so we have R equivalent as 1 by R plus 1 by R plus dot 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 1 by R N. So if N number of resistance is there, so it will be N by R. So R equivalent will be equal to R by N. So this is what happens. Now if we talk about the total resistance including external resistance, so see the circuit will become like this. This is R by N and this will be the external resistance. Okay. So the resistance, total resistance will be R, capital R plus small r by N. Now the current, what about the current? Current I is equal to EMF by R plus N, that is total resistance. So when we do this, so we will have a equation I is equal to NE by NR plus small r. Okay. So this is the equation of the current when it is combined in a parallel. Now the equivalent EMF of the cell is same as they have a single that of a single cell. The reciprocal of the total internal resistance is sum of the reciprocal of the individual internal resistance. So this is what we have done. Okay. So I is equal to NE by NR by R. Now if external resistance is very much smaller than R by N, so we need to put R as 0, so we will have NE by R. If external resistance is very much greater than this, so the current is E by R. So what we see here, that the current increases in this case. So if external resistance is smaller as compared to the internal resistance, so we should connect it in the parallel circuit. So what is the conclusion? That when an external resistance is negligible as compared to the internal resistance, then the cell are connected in a parallel to get the maximum current. Okay. So this is what about this class. So I will discuss Kirchhoff law in the next video. Thank you for watching my videos.